Hello, everyone. My name is Ryan. I am a member of the Arkansas Department of Health. I'm an environmental health specialist. And today I'm going to be giving you guys a talk on particulate matter and urban air quality in downtown Little Rock and just kind of Arkansas in general. So, we're going to be talking about today is, first of all, what particulate matter even is, and why does it matter to you? What does air quality do, and why does it affect you and your health? And then what you can do to help protect yourself and then others. So we're going to start off first with what particulate matter is. So particulate matter is the sum of all solid and liquid particles suspended in air, many of which are hazardous. This mixture can include both organic and inorganic particles, such as dust, pollen, soot, smoke, and liquid droplets. These particles vary greatly in size, composition, and origin, and we'll be talking more about size, composition, and origin here in just a minute. So basically what particulate matter is just things in the air, right? So it can be actual broken down pieces of other objects, such as primary particles, which are directly formed, such as when fuel is burnt, or they can be secondary particles, which is when they're indirectly formed, when gas in the air already that gets kind of condensed into a particle that you could then breathe in. So particulate matter basically is just kind of the sum of everything that's in the air. And then the size, composition, and origin of those particles is what makes them particularly dangerous. And so the size is specifically important. It's determined by the composition of the particle and the aerodynamic properties that gives it, because different sizes can go further down in your lungs. Obviously, smaller particles can go all the way down into your lungs, while bigger particles get trapped in some of the bigger airways in your lungs and can get coughed up in mucus. But smaller particles can get their way all the way in, and when they get all the way to the end of your lungs, down to the alveoli, that's when they can start causing damage. So most particles have an irregular shape. So size is based off an idealized sphere, described as an aerodynamic diameter. Also just called the particle size, obviously. Particulate matter, the sizes, I will be referring to them as PM10 or PM2.5 in the future. Based on size, they're usually categorized into two groups. You have the coarse fraction, which are the larger particles, which sizes ranging from 2.5 micrometers to 10 micrometers. And so you can already kind of get a measurement of how small this is. A micrometer is 10 to the negative sixth meters. So it's very, very small. Even the coarse fraction, which is the bigger particles. The fine fraction is less than 2.5 micrometers. And the ultrafine is a portion of the fine fraction under 0.1 micrometers. And those are extremely, extremely, extremely small. And do not contribute, from what we understand, to most of the problem. So I have a little graphic here to kind of give you a example of kind of what kind of size of particles we're dealing with. 90 microns is basically a grain of sand. Human hair is about 50 to 70 microns, and so 10 microns, which is the size of coarse particles, which is the bigger particles that we're referring to. About 5 of those is one strand of your hair, and then 2.5 particles, obviously, 5 of those or 4 of those is about the size of a 10. So the particles we're dealing with are very, very, very small. And that's kind of why they cause problems, is because they can get all the way down into the depths of your lungs, get eaten up by your body, your immune system in your lungs. Your body doesn't know what the heck it is. It starts sending out a bunch of signals saying, hey, we've got something crazy over here. It starts making inflammation, and then your lungs start getting damaged. And so we'll talk about more of the health hazards here in a little bit, but I just want you to kind of understand why these particles are so dangerous is because they are so small. So coarse and fine particles are the two main groups that we talked about, and so examples of each. So coarse particles, they're usually caused by breakup of larger solid particles, which usually comes from things like dust, so from dust from roads or anything like that. Agricultural processes of grains and corn, kind of like the processes involved with that. Uncovering soil or mining operations, kind of back to dust. Anything to do with outdoors. Pollen, grain, mold spores, plants, insect parts can also contribute to that. Also, if you live near the sea, which I know we don't, but if you do live near the sea, evaporation of sea spray can produce large amounts of particles, mostly sea salts, and things that can get released from the ocean if you live near there. And I have a little graphic here. Basically, it's just kind of the burning and breakdown of other bigger particles is what gives you coarse particles. Fine particles, on the other hand, are usually formed from gases, and they're formed through a process called condensation. So this is kind of whether when other gas particles kind of condense onto one and kind of form together, that's where they can basically two smaller particles come together and make one bigger particle. And then the particles produced this way are called secondary particles, obviously because they're not primary because they weren't made just from something breaking down. They're secondary because there are other gases kind of condensing into liquid and then forming together and then making a particle. And so that's how most ultrafine particles are made, and then ultrafine particles can come together and make fine particles. In the graphic down here in the bottom right, you can kind of see, so with water vapor and ammonia and other gases in the air, they can kind of react with each other, condense into like an actual particle, and then that particle can then go on to be breathed in by you. So why does that matter? So what's the big deal? So there's stuff floating around in the air. If it's so small, like what's the big deal? So accumulated data suggests that particulate matter exposure may lead to pulmonary inflammation. I was referencing this a little bit earlier. Basically, when these particles get down deep in your lungs, your body's immune system will eat them up, and they don't know what it is, so they start sending out signals to cause inflammation because they're trying to kill it because they don't know what it is. So chronic inflammation is a hallmark of lung diseases such as asthma and COPD, and may be aggravated in susceptible groups by particulate matter pollution. So basically, anybody that already has asthma or COPD can get exacerbations by these little particles because these particles will get down in your lungs, cause inflammation on an already inflamed or damaged set of lungs in the case of asthma or COPD. In 2004, the American Heart Association published a scientific statement that concluded studies have shown an increased risk for cardiovascular events in relation to both short and long-term exposure to ambient particulate matter. So not only can they cause lung inflammation, they can cause cardiovascular inflammation, so your heart can get damaged. So people that already have cardiovascular disease have a long-term exposure to particulate matter that can cause even more damage to them. And long-term ambient exposure can lead to a marked reduction in life expectancy. It's primarily due to the increased cardiopulmonary, which we talked about, and lung cancer mortalities. So basically what happens is that inflammation stimulates your lungs to go into overdrive, which can lead to lung cancer in the long term. So overall, no good for your lungs and for your heart. So exposure on a global scale kind of varies. This is a really busy graph, so I'll kind of walk you through it. This is a graph just indicating the specific portions contributing to total particulate matter under 2.5, so fine particles that we discussed earlier. And if you look over the USA, we have a big yellow section, which is from unspecified sources of human origin. And that category mostly includes secondary particles formed from unspecified sources of human origin, such as long-range transport, shipping. Those are the secondary particles we talked about earlier, where it's other gases in the air that kind of condense onto each other. So those are the smaller particles. So as you can see, Canada and USA mostly have those smaller unspecified sources, while the rest of the world has big sections made up of traffic and industry, and even some from domestic fuel burning. We have contributions from those, obviously, but our major source is unspecified sources of human origin. So exposure in Arkansas specifically is a little bit different because no matter where you go, it's important. But here, there have been studies that show that air pollution concentrations are associated with significant health burdens, and even more so for poorer counties. So as you might know, Arkansas is not one of the most well-off states, especially in some of our more rural counties. And studies have shown that in poorer counties, the life expectancy loss due to particulate matter that is under 2.5 microns, which is the particles we're talking about right now, was the largest around states such as Arkansas. So I think that has a lot to do with our rural population and our poorer counties. So exposure here is explicitly important for our health. So on an even more local scale, what we can deal with here is mostly has to do with motor vehicle emissions, especially from coal combustion, as well as the secondary particles, which we've been talking about. Toxicology studies have shown it also has a lot to do with internal combustion engines, so your cars. Coal burning and wood burning have a big influence as well. So if you have a wood burning stove or anything in your house that uses wood, like a fireplace, that's also some toxic chemicals that you can be breathing in. In comparison, the windblown dust seems a less critical source here to us. And personal exposure is also quite important for us here, as tobacco smoke is obviously, as many of you probably know, a very negative source of pollution. And if you are experiencing that on a regular basis, that can really lead to some negative exposures as well. So, what can we do to limit our exposure to these negative effects in the air? So, weather apps commonly have air quality sections that can warn you about days with poor air quality. I pulled this screenshot on the left. I took this on my phone on the Weather Channel app. I went down and I went to air quality and I went over to the breathing section. And it told me apparently today's breathing comfort is good. So that's something anybody can do. You can check that out. I'm not 100% if the Apple Weather app has that on theirs, but anybody can go download the Weather Channel app and just scroll down and go look at the air quality for today. And you can use that every day. Basically, they use coagulated data from lots of sources to give you a good representation of what the air quality is looking like for that day. On days with poor air quality, I would advise to stay indoors with closed windows. Most people stay indoors anyway, whether it's at work or at home. But if it's a day with particularly bad air quality, just shut those windows. Closed windows can reduce air exchange rates by about 50%, leading to reduced infiltration of ambient air pollutants. So that'd be something that you could do that's pretty easy. You can also update the air filters in your home. Under typical settings, the 1-inch and 5-inch pleated media filters cause a 32% and an 80% decrease in particulate matter under 2.5 microns, respectively. Now, the most common one that most people have that I have in my home is the 1-inch. But if you are worried about this, if you are high risk, you can potentially switch that to the 5-inch pleated media filters that will decrease the amount of exposure by roughly 80%. And even more things you can do to limit your personal exposure include avoiding outdoor activities when air pollution is high. So, like we were saying earlier with that app, you can check when air pollution gets a little too high, and you can avoid outdoor strenuous activity. So, if you were going to go on a hike, but you check the weather app and see that it's a little too high for you, you can maybe reschedule that for a different day. Another interesting thing is that ultraviolet light from the sun actually activates the chemical reactions that form ozone. This generally leads to higher concentrations of ozone in the late morning through early evenings. So if you do want to go outdoors and go on a run or a hike or any kind of outdoor activity, maybe early morning or later in the day, once that UV sunlight kind of trims down a little bit, leading to less exposure on the outside. If you do like to run outdoors, try to move your run away from high traffic areas. So, as we discussed earlier, even though our main source of pollution here in the United States is from unspecified kind of secondary particles, traffic does contribute quite a lot to our personal experience, right? So, our personal exposure. So, if you try to move your runs away from areas with high traffic, studies have shown that concentrations of traffic-related pollutants decline in steep gradients with distance from roadways. Makes perfect sense. The further you run away from a big highway, the less pollutants you're going to get from the roads. So I would suggest running on trails. We have plenty of parks and trails that you can run here that are not right in town where you'll be getting yourself exposed to a lot of traffic. And then finally, high-risk individuals need to be on top of their personal management of any underlying diseases, as there's no specific plan to minimize risk in this population. I suppose you could be wearing a respirator every day, but I know that's not very feasible. So people with higher risk diseases, such as cardiovascular disease or COPD, need to be on top of their personal management, so that way the effects of particulate matter and air quality on them specifically are not much higher than the natural population. Okay, and that's pretty much all I have. I appreciate you all listening to me today. I hope you have learned something and take a little bit of what I've said to heart and try to just keep an eye out on the air quality and understand why it's important to you. And just know that if the air quality is a little low, maybe you should just stay inside for the day. Thanks, everybody. Bye.